Hi everyone, welcome to homework for lesson 40. Let's go ahead and get started with number 1. The bag contained only red marbles and white marbles in the ratio of for every 3 red we have 2 white. So we want to know what fraction of the marbles were white for A. Now, in order to find the fraction, we have to know the total number of marbles. Now in the ratio, the total just comes from adding the numbers that are being compared. In this case, 3 and 2. So when we add those, that gives us a total of 5. And then the amount of white marbles will be your numerator for the fraction. For B, what is the probability that a marble drawn from the bag will be white? Well, the probability is going to be exactly the same as the ratio for white marbles to yellow marbles. So if you look at number 1, A, that fraction is actually going to also be the probability as long as they're both simplified. Number 2, John ran 4 laps of the track in 6 minutes and 20 seconds. How many seconds did it take him to run 4 laps? So for this question A, we have to take the 6 minutes, turn it into seconds. We do that by multiplying 60 by 6. Whatever your sum is, whatever your factor is, whatever your product is there, you then add it to the 20 to find the number of seconds that it took him to run the 4 laps. And then B, John's average time for running each lap was how many seconds? Well, you have to take the number of seconds that he ran divided by 4. Now, if you go back to your answer from A, that tells you how many seconds he ran total. You would divide that amount by 4 to find out how many seconds it took him to run each lap. Number 3, the Curtis's car traveled an average of 24 miles per gallon of gas. If they keep going at that rate, how far could the car travel on a full tank of 18 gallons? Well, if every gallon gets them 24 miles, then 18 gallons can get them 1 mile or 28 miles for every gallon, which gives you a total of 24 times 18. That'll tell you how many miles they can travel on a full tank of gas. Number 4, at sea level, water boils at 212 degrees Fahrenheit. For every 550 feet above sea level, the boiling point of water decreases by about 1 degree Fahrenheit. So every 550 feet you go up, the boiling point decreases by 1 degree. So if you're at 5,500 feet, water boils at about 202 degrees Fahrenheit. That's a 10-degree drop. How many degrees hotter is the boiling temperature of water at sea level than at 5,500 feet above sea level? So that, again, how many degrees hotter, you would just take the 212 degrees at sea level, subtract the 5,500 boiling point, which is 202, to find the difference and to find how much hotter boiling temperature at sea level is than it is at 5,500 feet above sea level. So basically, the further up you go, the less heat you need to boil water. Now, for B, at the summit of Puncak Jaya, the highest mountain in Indonesia, water boils at about 183 degrees Fahrenheit. About how many feet above sea level is the summit? So this is a multi-step problem because the first thing you have to do is you have to figure out what the difference in degrees is, right? Because for every degree that you have, it represents a 550-foot difference in sea level. So all that's left to do for this is to subtract, and once you've done that, you multiply by 550 to find out the height of the summit of Puncak Jaya. I think I'm pretty sure I'm saying that incorrectly, but that's my best effort, given that I'm only going off of how it's read and not how I've heard it said. All right, for number 5, the length of the rectangle at the right is twice the width. So the length is double the width, which means the width is then the opposite of double, which is half. So the width is half the length. which is 35. So then to find the perimeter, you have to add up all of the four sides for A, and then the rectangle opposite sides are equivalent. To find the area, you just multiply the length times the width for B. Keep in mind that area will be in units squared. Perimeter will just be the regular units. 6a, we're going to diagram the statement. So we're going to make a little box. Then we answer the questions. 5/8 of the 200 sheep in the flock graze the meadow. The rest of them drink from the brook. So we got sheep that are grazing. We got sheep that are drinking. Not ship, because that is not the plural of sheep. 5/8. So that means we have to split this up into 8 equivalent sections. So that's the first thing we're going to do to diagram this. We know that it has to be a total of 200 sheep. And so what we have is that 5/8 of them grazed in the middle. So that's 5 of these sections are in the middle, and 3/8 are drinking from the brook. So how many sheep grazed in the meadow? Well, if these are 8 equivalent sections, we have to take 200 divided by 8 to find how much is in each section. To find how many sheep grazed in the meadow, you would basically count 5 of those sections, because it says 5 of the 8 groups were in the meadow. And that leaves us that 3 of the 8 groups were out drinking from the brook. So it comes down to these 5 sections total are how many were in the meadow, and these 3 sections combined are how many were in the brook. As a reminder, 200 divided by 8 will give us what the value of each of these sections is. 7, AB is 30 millimeters. Okay, simple enough. CD is 45. The entire thing is 100. We gotta find BC, but in centimeters. So this is actually gonna be a multi-step problem. First and foremost, you want to take away the 2 sections there. So that's gonna be 100 minus 75. So that's gonna give us, 25, which is all well and dandy, but that's millimeters. We want centimeters. And we know that every 10 millimeters is 1 centimeter. So we can divide 25 by 10. We'll end up with a decimal amount. Remember that with metric system, we use decimals, not fractions. So make sure that you divide using long division. Numerator goes on the inside, and denominator goes on the outside. Add a terminal 0 if you need to, which, spoiler alert, you will need to. And just make sure you divide. Number 8, round 0.08 and then 3 repeating to the nearest thousand, which is the third decimal place. So you look at the number directly to the right to see if it will go up or stay the same. Everything on the left stays the same. And then it's up to you to determine whether that's going to remain a 3 or become a 4. And to nearest 10th, similar story. Underline the 10th place. Look at the number on the right. Use that to decide if it will go up 1 or stay the same. Everything to the left stays the same. And then it's up to you to determine whether that goes up 1 or remains. Number 9, use words to write each number. So we have the typing function that I can use. So remember that 12 is 12, that any decimal can be represented in word form as and then you have the number itself, which is 54, and then the place value. So that's going to be up to you to determine what the place value of the decimals are. And that's going to be the final part of this. Just remember that with decimal place value, it is th. So tenths, hundredths, thousandths. It is different than whole number place value. Slightly different. Number 10, 10 and 11 hundredths. Similar story when we have a mixed number. You get the whole number, you put the and, you put the 11. But now the decimal place value is actually the denominator in fraction form, but however, it is still in th, so tenths, hundredths, thousandths. For number 10, the coordinates of the three vertices of the triangle are negative 2, 5, 4, 0, negative 2, 0. What's the area of the triangle? I can tell you that it would be so easy to just draw this on the coordinate plane and, from there, decide, you know what? Um, I'm just going to count the squares on the inside, but we're not going to do that. So we have negative 2, goes up to 5. That's well and dandy. We have 4, 0. So 4, 0 is there. And then we have negative 2, 0. So negative 2, 0 is here. And this might, the fact that I'm doing this without a coordinate plane might seem like it's unnecessarily confusing, but I promise that you will still get an answer that makes sense. Now I'll explain how we're doing this even without a coordinate plane. So since this section here goes from 0 to negative 2, we know that because we're given from this point, negative 2, 0. That tells us that this has an absolute distance of 2, right? And then this point here is 4, 0, so that gives us this absolute distance of 4. So that tells us that the base of the triangle is actually 6 units long. So we have the base is 6 units. Now we multiply by the height. Now the height is from negative 2, 0 to negative 2, 5. So what we're looking at is the y value. It goes from 0 to 5, which gives us a height of 5 units. And from there, we use the rest of the formula for the area of a triangle. After you multiply the base and the height, you just take half of that product, and that gives you your area in units squared, since they don't give us units for measurement. Number 11, what decimal number names the point marked B on this number line? Just remember to add terminal zeros to the points in between, and then just count in between, 71, 72, 73, so on. Keep in mind that it will be a decimal number. It is going to be a 7 in the ones place, tens place, so then it's up to you to determine what the value of the hundreds place is. Refer to the figure below to answer problems 12 and 13. Find the measure of each angle. We have ACB, so that's this angle right here. So what we know is that all the three angles in the triangle have to be 180 degrees. So we can take 180, and then we can subtract the sum of 70 and 75. So the first thing you want to do is you want to add 70 and 75, and then you want to subtract that sum from 180 to find the value of ACB. Now for ACD, it's going to be a little bit different because you do it one of two ways. Notice that ACD and ACB are adjacent and supplementary. So what that means is that whatever the value for this angle is, C, if we subtract 180 coming from the fact that it's a straight angle, subtract the value of C of angle ACB from letter A, so I guess I'll put letter A so we don't get confused. That's going to give you the measurement for ACD. Now DCE is interesting because you'll notice that angle and ACB are vertical angles, which means that the measure for letter C and the measure for letter A are exactly the same. They're equivalent. Angle ACD is supplementary to ACB. Name another angle supplementary to ACB. Well, another angle that forms a straight line with our ACB angle, you'll notice, is actually this angle. See how they make that straight line? So your job is to name this angle right here that we have. This one right there. Keep in mind that the letters on the outside doesn't matter what order they go in, but the vertex in the middle, that goes in the middle. And then the other two letters doesn't matter where they go. All right. 14a, which property is illustrated by this equation? We're multiplying by a fraction that is equivalent to 1. Anytime you multiply by anything that's going to be equal to 1, you're dealing with the identity property of multiplication. Even though 10 out of 10 doesn't look like 1, its functional value is 1. The thing it assisted with us here is in turning this from division with decimals to just division with whole numbers. So we get to letter B, find the quotient. Now it's just a matter of using either mental math if you're able to, or just using long division to divide. 15, solve. So this is cross multiplication. We're going to have 8 times 25 equals 10W. 8 times 25 being 200. 8 times 5 is 40. 8 times 20 is 160. 160 plus 40 is 200. And then we're going to use the inverse operation to solve for W. And we're halfway through. So another proportion problem, we cross multiply. 9n equals 1.5 times 6, which is 9. Then we divide and solve. So for 17, similar story. 9m equals 15 times 12. I'll leave that up to you to simplify. And then just don't forget that you can either divide and then cancel, or you can just multiply and then divide by coefficient. 18, a plus 1.8 equals 4. We're going to add the terminal 0 there so that we have the same number of digits after the decimals. We're going to subtract 1.8 from both sides. And so a is equivalent to the difference of 4.0 and 1.8. For 19, again, we're going to add a terminal 0 so that they both have 2 digits after the decimal. But since it's subtraction, and since the subtrahend is the value given, we're going to add to both sides. Instead of doing a switcheroo, we're just going to add. Make sure that you drop your decimal down. Make sure that you carry over. 20, 1.2 meters minus 12 centimeters equals how many meters? So 12 centimeters has to become meters. We know that we're going to have to divide it by 100. So that's going to actually give us 0.12. And we're going to have terminal 0 here so that they have the same number of digits. Remember that there are 100 centimeters in a meter. Centi meaning cent, which, you know, like there's 100 cents in a dollar. There's a reason they call them cents, because you need 100 of them. And then you just subtract. 35 15 hundredths times 5 hundredths. I can ignore the decimals for now and just multiply. 15 times 5 is 75. And then count the number of digits after the decimals. 1, 2, 3, 4. And you're going to move the decimal to the left. 1, 2, 3, 4. Any blank spaces? You know, Taylor Swift would write her ex or future boyfriend's names. We are going to put zeros where there are blank spaces. All right, 22, 15 times 1.5 is the same thing. Ignore the decimal for now. 15 times 15, 225. That's a perfect square. And then count the number of digits after the decimals. Only 1. So then we move the decimal to the left once. 23, long division. Place the decimal above itself in the quotient and then ignore it. So decimal goes up top, and then you just divide like you normally would. Make sure that you have everything nice and neat and organized so you don't get confused. 24, 5.6, subtracting the difference of 4 and 1.25. So again, you're going to need to add terminal zeros. Subtract 4 and 1.25. Once you have that difference, then you're going to subtract that from 5.6, and we're going to add another terminal 0 so that the number of digits after the decimals match up. And keep in mind that your decimals also have to line up for this to work. 25, we're going to add 3.14 and 1.20 first. Once you've added those, you're going to subtract that sum from 5.00. And again, we add terminal zeros so that we have the same number of digits as after the decimal as in both terms. 26, 6 1/4 times 1 3/5. Since we're multiplying, we want mixed numbers turned into improper fractions. 6 times 4 is 24. Plus 1 is 25. Keep the same denominator. 1 3/5. 1 times 5 is 5. 5 plus 3 is 8. 8/5. And then we can multiply straight across and then simplify. Or you can cancel. I would have preferred to cancel, personally speaking, but that's up to you if that's what you want to do. And then we have 27. So we're gonna, everything needs to be an improper fraction. 5 times 6 is 30. 30 plus 5 is 35. So you have 7 over 1 divided by 35 over 6. And then just remember that since we're dividing fractions, we're not actually going to divide, we're going to multiply by doing keep the first fraction the same, change division to multiplication, and take the reciprocal of 35 over 6, and then multiply straight across. Do not cross multiply. This is cross multiplying, this is multiplying straight across. There is a difference. Number 28, 8/15 plus 12/25. It's a little tricky, but we do need a common denominator between 25 and 15. So you find the prime factorization of each. 5, 3. 25 is 5. 5. Take the biggest group of each unique factor. 5, 5, and 3. Multiply them to get you 75. So now 8/15 has to turn into a fraction that is out of 75. And 12/25 also has to turn into a fraction that is out of 75. Once you have your two fractions out of 75, you can go ahead and add the numerators. Again, these are equivalent fractions, and you could actually solve for this using cross multiplication if you wanted, or you could just multiply by the common factor. In this instance, we're going to multiply by 5, and then in this instance, we're going to multiply by 3. All right, 29, 4 2/5 minus 1 3/4. Same thing, got to find the common denominator first, which is 20. We're going to multiply that by 4, multiply this by 4. We have 4 and 8/20. Then we're going to subtract 1 and 15/20. You'll notice that, we have to subtract the fractions first, but you cannot subtract 8/20 and 15/20. So we're going to have to regroup. We're going to borrow from the 4, turn it into a 3, and we're going to add 20 to the numerator here, which will make it 28. And then from there, now you can subtract the fractions and then simplify if you can, and then subtract the whole numbers. Number 30, the perimeter of a square room is 15.84 meters. We want to estimate the area. How do we make our estimate? Well, we could do this a couple ways, but if we're going to estimate, then we're going to round. So the perimeter is going to be 16. I'm going to round to the nearest whole number. I look at the tens place. It's bigger than 5, so the 5 should move up to 16. So if the perimeter is 16 and it's a square, that means all the sides are equivalent. So we take 16 divided by 4, which gives us 4 meters per side. About. Again, this is an estimate. So what's left to do? Well, what's left to do is just find the area. We find the area when we're multiplying the side times the side, and that's going to give us meters squared. And how do we make our estimate? We rounded the perimeter of the square room to the nearest whole number. We divided that by 4 because it's a square, and all the sides are equivalent. And then we multiplied one side measure times the other side measure to find the area. All right. This has been your homework help for today. For extra credit, since they mentioned Indonesia earlier, wonderful country, capital of Indonesia will be your extra credit. Just write it anywhere on there, and you will receive extra credit from me, Mr. C. Any other people out there watching this who do not have the privilege and the honor of being my student, you can go ahead and write the capital of Indonesia on your homework and see if your teacher will give you extra credit. I mean, it's worth a shot. Why not, right? All right. Hope you found this video useful. If you did, hit that like button, hit subscribe. Hope you have a great day, and we'll see you later.